So assuming that the heights of college women are normally distributed with mean 62 inches and standard deviation 3.5 inches, what percentage of women are taller than 55 inches? So obviously, X follows normal with mean mu equals 62 and sigma equals 3.5. We need probability X bigger than 55. Okay, so we shall draw diagrams first. My diagrams are not to the scale. So the area we need is this. And we will do our usual trick of probability to the right. That means area to the right is 1 minus area to the left. And how do you find area to the left? First find the z-score. That's 55 minus 62 divided by 3.5, which is minus 2. And if you go to the z table and look up minus 2, you shall get 0.0228. So probability X bigger than 55 is 1 minus 0.0228, which is 0.9772. Okay, so here X follows normal with mean mu equals 65 and standard deviation sigma equals 3.5. We want probability X less than 68.5. So for 68.5, the z-score is 68.5 minus 65 divided by 3.5, which is 1. And if you look up the z-table for 1, you shall get 0.8413. So your answer is 0.8413. Now X follows normal with mean mu equals 64, sigma equals 1.5. You want probability X lies between 68.5 and 65.5. So as usual, find the z-score. This one's 3 and this one's 1. And if you go to the z table, for 3 the value is 0.9987, and for 1 the probability is 0.8413. So the probability you are looking for is 0.9987 minus 0.8413, which shall be 0.1574. Question 4, next question. So this problem is in actually 2 parts. The incubation time for chickens is normally distributed with a mean of 30 days and standard deviation 2 days. So for each chicken, the incubation period is normal with mean. So x follows normal with mean mu equals 30 and sigma equals 2. So next part of the question they're actually asking is, if 1,000 eggs are being incubated, how many chicks do we expect to be hatching in between 24 and 26 days? So first of all, what's the chance? What's probability x lies between 24 and 26? So you can find the z-score of 26 and z-score for 24, and then find the probability from the z-table, and then take the difference, and you shall find this to be 0.0228 minus 0.0013, which is 0.0215. The next part of the question, the second part is, so there are 1,000 eggs like this, and for each of them it's normal like this. So there's like x1 which follows normal with mean 30, 2, x2 follows normal 30, 2, dot dot dot, and x1000 which follows the same normal 30, 2. And they are asking that how many chicks do we expect? So for how many of them? Okay, so for each of them, suppose we call success if, suppose, sorry, so for x1, it's success if x1 lies between 26 and 24. And you define success the same way for each of them. For x2, it's if success if x2 lies between 26 and 24. And same for x1000. So we know that probability of success is 0.0215. That's like P, and number of trials N is 1,000. So suppose Y is number of success out of 1,000. So we know that Y follows binomial NP. So each egg is a trial, and for each egg we can get success or failure. So y follows binomial NP. So they are asking how many chicks do we expect? So what's the expectation? What's the mean of y? What's the mean of y? So we know that the mean of y, if y follows binomial NP, is n times p. So here in this case this will mean 1000 times 0.0215, which is 215.